Jai Hind, welcome to the course Network Analysis and Synthesis, and today I am going to discuss about the loop analysis using the graph theory. So, in the previous video lectures, we discussed the theory aspects, how to carry out the loop analysis in a network using the graph theory. Today I am going to take up some problems using the loop analysis in a graph theory. So the given problem is like this: for the given network, obtain loop impedance matrix and loop equations. So there are two problems. One is to find ZL is equal to Tysset matrix ZB transpose of the Tysset matrix, and second is VL is equal to ZL and IL, where the same symbols have their usual meaning. We have already explained how we will get these expressions in the previous video lecture. So, if you are going to carry out the loop analysis, so writing first, before writing the loop equations, what you have to do, you have to just take the precautions of these two things. What are these? It is convenient to write loop equation for a network containing voltage source but no current source. So, if the network is containing only voltage source, then it is very easy to apply the loop analysis. But if current sources are present in a given network, so what we will do? We just convert these current sources into their equivalent voltage sources. So, before carrying out the loop analysis, if there is any current source present in the given network, what you have to do? You have to convert this current source into its equivalent voltage source, and then you go for the loop analysis. What are the steps? Steps are first, draw the oriented graph of the given network. Okay. So, if the network is given, so what you have to do? You have to draw the oriented graph. Before drawing the oriented graph, we have to check whether your network is oriented or not. If network is oriented, if the direction of currents are given in the network, then you can draw the oriented graph. If the directions are not given, then first orient the network as per conventions having the current sources and voltage sources. Okay. So, in the present case, the direction of the currents are given. So, here you need not to orient the network. You straight away you can draw the oriented graph. Once you draw the oriented graph, the second step, take a tree. We know what is tree. If not given. So, in the some examples, it is mentioned that take these branches as tree branches. If it is not given, then select a tree. Third is find Tysset matrix. Denoted by VF. Okay. D, find branch impedance matrix. matrix ZV denoted by ZV. So this ZV is the branch impedance matrix and BF is the tie-set matrix and this is the BF transpose. So we can get these matrices from the given network. The tie-set matrix by drawing the oriented graph and selecting a tree, we can get the fundamental tie-set matrix, and by inspection we can write the branch impedance matrix. So multiplication of these three matrices will give this is the loop impedance matrix. This ZL is loop impedance matrix. Loop impedance matrix. Okay. VL is ZL-IL. Now VL is your tie-set matrix into voltage source plus tie-set matrix into branch impedance matrix into IS. So this we can get by using this expression, and VL we can get tie-set matrix into the source voltage vector. It is the number of branches into number of branches correspond to number of rows and one column, and BF ZV IS. So why we mentioned here, if the current sources are present, then these current sources must first be converted into their equivalent voltage source just to get rid of this matrix. If there is no current source, then you have to not do this exercise. Okay, BF ZB IS is equal to 0. So it is better to convert the given current source into its equivalent voltage source. So in the present case, we can see one is the voltage source of 5 volt and another is the current source of the 5 ampere. So first convert this current source into equivalent voltage source. Okay, so we can redraw it. So just I can write this here. So it is like this. J3 3J ohm, you can write this is the 2 into 5, so it is your 2 ohm, 2 ohm, 2 ohm. It is your 2 ohm and this is 5 into 10 volt. 10 volt. This is 2 ohm. It is given, then that is 5 volt. This is the orientation. This is J4 ohm. This is the dot and the direction of current. This is the dot, and this is J5. J5, J4 ohm. This is 2 and 5 volt. Okay. So direction in this like this. Now identify the number of nodes. So number of nodes is say and the branch number is also given. So this is branch number 1, this is your branch number 2, this is your branch number 3, this is your branch number 4, this is your branch number 5, and this is your branch number 6. So here we have, then you can identify the number of nodes. So this is number 1 node, this is number 2, this is 3, this is 4, this is your 5, and this is your 6. So this is the oriented network. So first step is draw the oriented graph. So we can draw the oriented graph. So oriented graph will be like this. This is node 1, this is node 2, and this is node 3. So direction of in this branch will be like this. This is your branch 1, and this is your branch 2, and this is branch 3. So this part. Now so this is branch 6, this is your 5, and this is your 4. This is node 4, 5, and 6. So to differentiate between the nodes and branches, nodes are just we encircle the nodes and we write the branches inside a bracket. So these are the branches, and so there are 6 branches and 6 nodes. Okay, look at. So this graph is disconnected graph. Disconnected graph. Why this is the disconnected graph? Because we are not able to reach from node 1 to node 4. There is no any path. We cannot reach from node 2 to 4, or 3 to 6, or 3 to 5, or 1 to 5. So this graph is disconnected because there is not a graph is said to be connected if there is at least one path between every pair of the nodes. So between 1 and 4 there is no any path, 1 and 6 no path, 1 and 5. So this graph is disconnected. So the selection of the tree, the concept of selection of tree is applicable to a connected graph. So if the graph is disconnected, what we do? We just take tree of the individual section, individual connected graph. So 1, 2, 3, this is the disconnected, this is connected. So tree is the concept of connected graph. For the disconnected graph, we have another term that is called the forest. So for the individual, for the each connected section of the graph, we select one tree. So the tree will be like this. So select a tree. Now select a tree. मैडम क्या हो गया ये select a tree. So if not given, so it is a tree. it is a tree. 1, 2, 3, 4, 5 and 6. Sorry. So you have to write the fundamental tie-set matrix. So we have to orient the fundamental loops, and the orientation of the fundamental loops are as per its defining links. Then we can write the fundamental tie-set matrix. So how many loops are there? There are two fundamental loops. Say this is your L1 and this is, say, it is your L6, corresponding to the link 1 and link 6. So there are two fundamental loops, so there will be 2 rows, and columns will be number of branches 1, 2, 3, 4, 5, 6. So 1, 2, 3. So 1, 2, 3. Orientation of 1, 2, 3 same as the its defining link. So it is 1, 1, 1. 4, 5, 6 is 0, and in the for the L6 1, 2, 3 0 and 4, 5, 6 1, 1, 1. So we have got the fundamental tie-set matrix. Once we got the fundamental tie-set matrix, we can get the fundamental transpose of the fundamental tie-set matrix. So it is, just write the transpose 1, 1, 1, 0, 0, 0, then 0, 0, 0, 0, 0, 0, 1, 1, 1. Now branch impedance matrix ZV. So ZV is a square matrix. Rows and columns are same, and it is decided by how many branches are there. So there are 6 branches, so it is 6 by 6 matrix. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now look at the impedance of this is Z11. So Z11 is 2. Z12. Z12. So there is no coupling between the branch 1 and branch 2. So it is 0. Z13 0. Z14 0. 5 0. 6 0. Because off diagonal elements are the mutual inductance. Okay. Now 2 1 0. 2 2. So 2 2 is J4 self inductance of the branch 2. 2 3. So 2 3 is, there is no coupling between 2 and 3, so it is 0. 2 4. So 2 4 no coupling, so 0. 5 0. 6 0. 3 1 0. 3 2 0. 3 3. 3 3 is J4. And 3 4. So there is coupling between the branch 3 and 4, and it is J2. So it is J2 0 0 0 0 4 3. So it is J2. 4 4 J5. Then 0 0 5 1 no coupling 0 0 0. Then it is minus J3. 0 6, it is 2. So diagonal elements are the self impedance of the branch, and whenever there is a coupling between the branches, we can have the off diagonal elements. So in the present case, we can see that there is a coupling between the branch 3 and branch 4, and we also see that look at here, current is this is a dot, this is a dot here, and current in the both the windings is entering. In the branch 3 the current is entering the dot, branch 4 current is entering the dot. So in that case the voltage developed by due to the mutual inductance will be positive. If suppose in one branch current is entering the dot and the another branch the current is leaving the dot, in that case the mutual voltage developed due to the mutual inductance will oppose each other. So, in that case we will take the negative sign. So, here all the off diagonal elements will be positive. You can see here this and this, because in the both the windings current is entering. If the current is entering, positive; if the current is leaving, then in that case also take the positive signs, otherwise take the negatives. So, once we have written the ZB, then we can find the ZL. So, ZL is loop impedance matrix is tie-set matrix, branch impedance matrix, and then the transpose of this matrix. So, on the multiplication we can get ZL is, it is coming like this. We can check, this is coming 2 plus J8 J2, then J2 and 2 plus J2. So, this is the loop impedance matrix. So, part 1 is, we got the part 1, now part 2. Loop equation is VL is equal to ZL IL, and VL is tie-set matrix into VS. Okay. So, we have got tie-set matrix. Now, the remaining is VS. So, what is VS? VS is the source voltage. How many branches are there? There are 6 branches. 1, 2, 3, 4, 5, 6. Okay. So, branch 1 having the voltage of 5 volt. There is no voltage in branch 2, so it is 0, 3, 0, 4, 0, 5, 0, and 6 having the 10 volt. So, this is the VS. So, we can multiply tie-set matrix, which is 1, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 1 with the this VS. So, we can get VL. So, VL is coming 5, 10. So, VL is coming 5, 10. VL is coming 5, 10. ZL is coming your 2 plus J8, J2, then J2, 2 plus J2. So, loop equation is VL is equal to ZL IL. So, it is 5, 10, 2 plus J8, J2, J2, 2 plus J2. And there are, this is IL1 and this is IL6. So, we can get this IL1 and IL6 loop equations. We can get the inverse of this matrix, 2 plus J8, J2, J2, then 2 plus J2, inverse of this into 5, 10. So, on the simplification of these equations, we can get the loop equations. Once we get the loop equations, we easily can get the loop equations means loop currents. Once we get the loop currents, we can get the branch currents. Once we get the branch currents, we can get the branch voltage, because branch impedance is given. So, multiply with the branch impedance, we can get the branch voltage. So, this way we can carry out the loop analysis of any network, whether it is simple or complex, using the graph theory. So, I am stopping here. Oh, thank you very much. In the next class, we will carry out the nodal and problems on the nodal analysis using graph theory. Thank you. Jai Hind.